So this is the last module, and which is independent than all earlier modules, which is not that way directly connected with electric and magnetic fields. Rather, this module is connected with circuit theory itself. I hope that everybody will look at the whiteboard. And sometimes in some universities this subject is, this module is there in the circuit theory. Somewhere it is clubbed in field theory. So it is quite different than what we have discussed till now. So till now we have never come across a situation where length of electric wire is mattering in any kind of electrical circuitry. Means till in our discussion till now we presume electric wire connecting two points makes them electrically one and the same. I again repeat, when you connect either AC source or a DC source, so it's a DC source, point A and point B, it's a load, then it will be a simple resistive load. It's a point C and point D, maybe a lamp, anything. And when you connect it using a wire is presumed to have zero resistance. It can't be zero, but it is extremely negligible, so that is ignored. And we presume that when we put the switch on during your childhood, there might have been a question how the lamp glows instantly, why there is no time lag. That question might have been crept up in your mind. So everything happening instantly as if these 2 points are same. Whereas when we talk about very long distance lines, this phenomenon needs to be re-looked into on two aspects. Number one is that a wire with zero resistance is not possible. We can't have superconductor. So it may have a small resistance, but some resistance. And we take it kilometers together, maybe at a distant place, or if we wind it out, we can have it at the same place, but it is of huge length. So when we talk about length of a pair of wires from one place to other with length in kilometers, whether the same phenomenon that point A and point C and point B and point D are electrically equivalent holds good or not. So it's a question under consideration. There are two aspects. Number one is that it will have some resistance. So for time being, we say that the superconductor is not possible, but we assume that superconductor is there. For time being, I say. So a wire made up of superconductor will not have a resistance. However, resistance is not the only electrical entity coming into picture, a parameter coming into picture. There are two more parameters. Those are capacitance, because even if it is vacuum, vacuum is having two properties, what we can say, major parameters called as permittivity and permeability, related to capacitance and inductance. Therefore, practically, we will go to practical thing later. Means vacuum is impossible, because if you are in atmosphere, there is air, but let us assume vacuum. Superconductor is impossible, but let us assume superconductor. So a pair of wires made up of superconductors of very long length in vacuum is free from resistance. Number one. Also, as it's vacuum, in practice, suppose if there are a pair of wires, just wires we connect, we are having a plug pin lamp and we are having twisted cable with plastic coating, and we connect it at other end. Where plastic is expected to have infinite resistance, but there is some leakage. So there is some conductance also. between two wires, those are not fully electrically isolated. There is some leakage resulting into conductance, that is G. It should be 0, that is resistance between two wires must be 0. But it must be infinite, conductance must be 0. So we assume that vacuum being perfect dielectric, there is no leakage. So we assume two things, vacuum and superconductor. When we assume vacuum and superconductor, still two parameters are there which are under consideration. Those are resistance and capacitance. But now, when we talk about resistance and capacitance, we have talked about inductance and capacitance. We have talked about an inductance like this. This is L. We have talked about capacitance. This is C. So these are lumped parameters. Means something having a capacitance effect between two terminals. So just like in say applied mechanics, which must have been there in your pandemic days, the question of loading you must have seen in videos. So if I put some point load here, some load is there at this point. Whereas if I put some such weight on the bar, then it is what is load at exactly this point you can't say. But overall, if it is 5 kg on a bar of 2 meters, 2.5 kg per meter is the load. Loading of a bar 2.5 meter per kg. Like that, now when I say that a long transmission wire is running like this, so it has got two parameters. So those who are present should not feel that they are making some mistake, because the absent students have to watch it, and so you are very much lucky that you need not have the notes. You can remember, or you are exempted, whereas the absent students are to prepare notes and put it on the Google Classroom, otherwise they will be defaulters. So it would be very, those who do not put the Google notes will be detained as XX. So let it be made clear once and for all. So with this at least it will motivate you to listen carefully. So we put a message also on the group, hoping that you will come with that message. So when I am having a long pair of wire, what we are having, there is a capacitance and inductance per unit length. Capacity is in between, actually it is like this. So how to show it? Can it be shown? Then I can say that I am having a small length like this of delta x. Then a delta x length will have got inductance of L and capacitance of C. It is actually inductance here, capacitance here, and inductance here also. Both ones will have inductance like this. Then what is done? There is a small approximation we can do. It is again an approximation. We can say that, means this infinite long wire, we can say that lower wire is as it is, and upper wire is having sections of length delta x. For each section of length delta x, we are having an inductor, a capacitor. Further an inductor, a capacitor, like this. What is this? And the parameters of inductor: L, Henrys per meter, C, farads per meter. So what is this inductance? L delta x. What is this capacitance? C delta x. This L delta x is C delta x. So this is L section. But rather than L section, it is more appropriate to further distribute properly. One more way is that delta x is divided into two parts. T, this is one. More approximation. So what is this? L delta x by 2. L delta x by and this is C delta X. And such sections connected each other. Is it right? So a transmission line, an infinitely long or substantially long transmission line can be modeled as such small T sections with inductance L delta X by 2 on each side and capacitance C delta X connected to each other. आम्ही काय केलंय ह्या दोन्हीचा इफेक्ट वर घेतलाय इथं सो दॅट इट इज इझी टू आता हे केलं असतं तर डिफरन्शियल इक्वेशन करायला अवघड झालं असतं आता हे सोपं झालंय अँड डेल्टा एक्स टेंड्स टू 0 डेल्टा एक्स टेंड्स टू 0 सो नाउ द क्वेश्चन इज हाउ डू यू प्रोसीड फर्दर लक्षात इज आयडिया क्लियर सो a long transmission line made up of superconductor existing in vacuum. So if it was not superconductor, what would happen? This is an ideal transmission line of superconductor. The superconductor नसता तर काय आलं असतं? What would have additionally come? Resistance, where in series with inductance. R delta X by 2, R delta X by 2. If this was not superconductor, and if it is in vacuum, but if it is in air, what would have happened? Ideal superconductor in vacuum. R 0, L is there, C is there, and one more thing 0, leakage 0. So leakage is reflected by conductance G. So if it was not vacuum but air, what would have come in parallel? Here, this is G delta X. Is it right? So we first go for ideal case R and G at 0. It is lossless. It is a lossless transmission line, and then we go for a practical transmission line which is having R small but not 0, G very small but not 0. Right? So now we move next. So when I have got such a line, now one important thing is that a transmission line, on the transmission line, no 2 points are electrically equivalent. No 2 points on the transmission line are electrically equivalent. Means till now what we are doing, we were finding out we had a circuit. In a circuit we apply some signal. So we say V1T, we apply V in T, we get VOT. In between we may get VAT, VBT. In different paths we may get I1T, I2T. So what we were doing, we were finding out electric voltages at different points. Means voltage at a given point was a function of time, and the points where we were calculating or trying to map, trying to figure out, trying to list voltage were finite in number. A path thick answer. But now what happened? The transmission line is continuous. So what you can have, you can get, and if पूर्वी क्या होता, when we had a lumped parameter, means we were applying input, we were having some A, B, C, D, E, F. Let us see, or we can have common ground, so that's not a major issue. So this we say common. But anyway, B, C, D, F. So V1, this is V2, this is V3, right? But here, at any point you can measure voltage throughout the length. Transmission line is now of some length which can go into infinity. So this is the direction x side. So earlier, when in circuit theory, the electric points where we were measuring electric parameters, say voltage, were finite in number. So V1t, V2t, so this is V1t, this is V2t, this is V3t, this is V4t. But now those are infinite. So when those are infinite, the voltage means voltage is a function of time at different points. So V1t was one function, V2t was the other function, V3t was other function. We never said that voltage as a function of length and time, or means we were up till now we are only conversant about voltage as a function of time. But now what is happening? X is continuous. So if I plot a graph of voltage between these 2 points, there will be some voltage. Means if I am an observer, I can observe various voltages at different length at different times. So I can say that voltage now is a joint function of 2 variables, Vx comma t. So Vx comma t, this Vx comma t reduces to Vt at given x or Vx at given t. So मराठी सांगतो, म्हणजे आता ह्या क्षणी इथं व्होल्टेज किती आहे, इथं किती आहे, इथं किती आहे, इथं किती आहे, इथं किती, वेगवेगळ्या दिलेल्या वेळी फोटो काढता आला मला तर, किंवा दिलेल्या पॉइंटला वेगवेगळ्या व्होल्टेज. म्हणजे व्होल्टेज म्हणजे ट्रान्समिशन लाईनवर ज्या 2 लाईन आहेत, एकाच अंतरावर लाईन टॉप टू बॉटम लाईन मध्ये किती व्होल्टेज आहे त्या पॉइंट्सला, ते इकडे मागे घेऊन चालणार नाही, त्याच ठिकाणी घ्यायला पाहिजे. Vx इज Vxt, म्हणजे दिलेल्या रेफरन्स पासून x अंतरावर दिलेल्या वेळी व्होल्टेज किती आहे. सो V2,3 म्हणजे व्होल्टेज at a distance between the points on the transmission line, upper line to lower line, at a distance 2 meters from reference at 3 seconds. This is single value. This is one dimensional. Remember, this is one dimensional. म्हणजे व्होल्टेज जे आहे ते काहीतरी पॉझिटिव्ह का निगेटिव्ह असणार आहे दिलेल्या वेळी दिलेल्या ठिकाणी. सो इफ x is constant, voltage is a function of time. If t is constant, voltage is a function of distance. Voltage function of distance. So this is a joint function of x and t. Right? Now we proceed with very interesting thing is that what is a differential equation? Means there is a very interesting question. It's a very abstract question which you must not have come across, and none of you must have gone through the Google or some kind of lectures to find it out. So when I have a transmission line like this, let this be infinite line. One end is semi-infinite also, one end 0, and there is no end, it's going on. So x. And what is differential equation? A differential equation is not an answer. A differential equation is a loser bound which will permit the things which can exist in a given situation. That doesn't mean that the things will exist. म्हणजे क्लॅरिटी यायला पाहिजे, फार महत्वाचं आहे. समजा एक इक्वेशन आहे, x x equal to sine omega t. What does it tell? That your x चाहिए तो x का को डायरेक्टली अपन vt is moving. Vt equal to sine omega t means it is an answer, it is solution, it is telling you what the voltage is. It is telling you what the voltage is. Is it clear? Whereas we are having d2 Vt upon dt square, d2 Vt upon dt square is equal to Vt. What does it tell? Or dVt upon dt plus Vt equal to 0. What does it tell? Or equal to something, say sin omega t. What does it tell? A set of right. So listen very carefully. Differential equation will not lead to a definite solution. Differential equation is just then there is means now let me get from you your understanding of differential equation. There are three situations. There is fixed equation, situation number 1. There is differential equation, situation number 2, and there is no equation, situation number 3. You got the case scenario. Differential equation, no equation, differential equation, and normal equation. So what is how will we characterize it? Normal equation आहे म्हणजे डायरेक्टली काय असणार आहे, निश्चित आहे. नॉर्मल इक्वेशन. डिफरन्शियल इक्वेशन म्हणजे काय असणे निश्चित आहे का? नाही. मग नो इक्वेशन. So how will you compare a scenario of no equation with differential equation? नाही कळलं पाहिजे. पण M1 M2 सगळं झालं, थर्ड इयरला आपण एक सिनारिओ आहे, काहीतरी सर्किट आहे आणि हे आउटपुट इथलं आहे VOT केस 1, VOT equal to sin omega t. VOT dVOT by dt plus VOT equal to 0. Case 2, case 1, case 2. आणि no condition, no equation, case 3. But how will you compare no equation? Case 1, case 2, no equation. Case 3, 1 and 2. How will you compare 2 and 3? How will you compare 2 and 3? Differential. In case 3, how many solutions are there? In case 3, hello, is it thinking of some solutions for case 3? For case 3, how many solutions are there? Infinite. For case 1, how many? Unique. For case 2? More than one? More than one? But infinity or not infinity? In this equation, how many? Infinity is possible. So now listen carefully. Case 3, the solution set is infinite. Case 3. Case 2 also, solution set is infinite. However, case 2 is a proper subset of case 3. You take a plane. If we take a point, a set of listen very carefully. A set of points which are lying in a given plane. Is it a finite set or infinite set? A set of points lying in a given plane, x plus y equal to 2. Infinite. Now, a set of points lying on the line in the given plane, finite or infinite? Infinite. But it is a proper subset. These are less, means there exist a set, there exist non-zero members who are in the set but not in the subset. Right? म्हणजे इक्वेशन नसेल तर काहीच रिस्ट्रिक्शन्स नाही. इक्वेशन नॉर्मल इक्वेशन असेल तर काहीच फ्रीडम नाही. केस 3 नो रिस्ट्रिक्शन्स. केस 1 नो फ्रीडम. Case 2 is in between. Some freedom, some restrictions. Though infinite means case 3 will permit every solution to exist. Case 3 will permit every solution to exist. Maybe that anybody can come anytime or he may not come. Case 1, everybody has to come every time. And case 2, that for these sessions everybody must come, or every student must come, means what can be the idea? For every suppose that there are 100 students and 50 lectures. So case 1, all 100 students should come for all 50 lectures. Case 1, complete restriction, no freedom. Case 3, any student can come or not come for any lecture. So it will lead to an extreme situation, all will come or no will come, nobody will come. And case 2, for every lecture at least 80 students should come, and every student should come for at least 40 lectures. Right? So that it reduces the permissible things out of infinite things. Then what will be happening at actual situation can't be told by second case. A differential equation ना solution मिळत नाही. तर differential equation काय मिळतं? तर differential equation ना आपल्याला काय पॉसिबल असू शकेल याचा एक कच्चा आराखडा मिळतो, आणि त्यातलं ऍक्च्युअल काय असेल त्याच्याकरता तुम्हाला जे भरपूर गोष्टी पॉसिबल आहेत त्यातली ऍक्च्युअल कुठली असणार ते दिले. आता हे तर खूप लिस्ट आहे, डबल व्हेरिएबल्स आहेत, एक्स पण आहे टी पण आहे. तर कधीतरी कुठंतरी काय होतं त्यावर नेहमी सगळीकडं काय असणारे अवलंबून आहे. म्हणजे कधीतरी टाइममध्ये कुठंतरी कुठल्या तरी एका पॉइंटला कुठल्या तरी एका वेळी काय होतं हे माहीत असेल तर डिफरन्शियल इक्वेशन म्हणून प्रत्येक कधी पण आणि कुठे पण काय असेल हे काढता येतं. सो नाव वी डेव्हलप डिफरन्शियल इक्वेशन. आता कसं डेव्हलप करणार डिफरन्शियल इक्वेशन? तर सिंपल आहे. T delta x L L delta S by 2 L L delta S बरोबर. Now this is x. Simple. This is a small t network. So इथं काय असणार? इथं voltage V x t. इथं काय असणार? V x plus delta x t. Sorry, x plus V x plus delta x t. बरोबर. करंट सुद्धा वेगवेगळा असणार. करंट सुद्धा वेगळा असणार. I आता टी लिहायची गरज नाही, आता लिहिले म्हणून लिहित चालतो. I delta x t, sorry, I x t. इथं काय येणार? I x plus delta x by 2 t. ये क्या है ना? I x plus delta x comma t. बरोबर. आता डिफरन्स लिखून द्यायचं आहे. कसं लिहिता येईल? Kirchhoff's law. Kirchhoff's law must hold good now. So how will you do it very effectively? Kirchhoff's mesh law and Kirchhoff's node law. अच्छा लगा? Kirchhoff's mesh law, Kirchhoff's node law. कसं होणार? Vx, t equal to काय ना? Vx, t equal to आता मी लिहिताना असं लिहितो. Voltage across याला मी L1 म्हणतो. म्हणताना याला L1 म्हणलंय, मुद्दाम याला L2 म्हणलंय. L1 ची व्हॅल्यू आहे L delta x by 2. Voltage across L1 प्लस voltage across capacitor. हे बरोबर आहे? हे बरोबर? आता voltage across इंडक्टर काय येणार? व्होल्टेज across इंडक्टर कसं काढणार? L di by dt. व्होल्टेज across इंडक्टर L di by dt. करंट इन कैपेसिटर मार. So I equal to C dV by dt आणि V equal to L di by dt. These are to be utilized. हे वापरायचे. हे वापरून लक्षात आलं का? हे वापरायचे. हे वापरून Kirchhoff's node law आणि Kirchhoff's mesh law हे वापरायचं, किर्चॉफ नोड लॉ, किर्चॉफ मेश लॉ, आणि हे पॅरामीटर्स वापरून हे करायचं, पुढे जायचं. आता आपण एल असू एल सी मध्ये येऊ, काय एल वन घेतलं तर खूप होतं. आता कसं कसं येणार, त्याला थोडीशी हिंट देतो. दोनदा डिफरन्शियल करायला लागतं, डबल डिफरन्शियल करायला लागतं. आता पहिला VL1/2 हे काय घेता येईल, VL1 कसं करता येईल, VL1 कसं घेता येईल, L di/dt. L di/dt. L किती आहे, L is L delta x/2 आणि di/dt ते कसं येणार. आता या नाव देर आर, म्हणजे आता पूर्वी जे आपण सर्किट थिअरी शिकलो आणि हे यात फरक येतो. काय फरक येणार, नाव यू शुड नॉट यू व्हॉट यू डुईंग, सोल्युशन दिलं त्याचं. तर सिन्स नाव एक्स द डिफरन्शियल इक्वेशन येणार आहे, डिफरन्शियल इक्वेशन येणार, फॉर दॅट व्हेरिएबल्स कुठले आहेत, इंडिपेंडेंट व्हेरिएबल्स. when you look at the transmission line, independent variable x and t, so difference, this will not be dv/dt, but these should now dabba v/dabba, because that time at that point dabba v/dabba आणि dabba v/dabba x पर्यंत, dabba v/dabba t, dabba v/dabba x. So ultimately Vx at t and Vc, आता हे Vc किती ऍक्च्युअली इथं हे जे आहे ते हे इथं काहीतरी डिफरन्शियल टर्म प्लस ही टर्म आहे V x plus delta x comma t, Vx plus delta x comma t, बरोबर आहे. सॉरी x plus delta x by 2 comma t, is it right. हे मध्ये हे डिस्टन्स हाफ delta x by 2, so this is voltage Vx plus delta x by 2. Sorry, x plus delta मग नाव व्हॉट विल कम, तुम्हाला थोडा आता आयडिया देतोय. ही टर्म इकडे गेली, ही टर्म उजवीकडे गेली, ही टर्म डावीकडे आली, तर काय होईल, Vx plus delta x by 2. आता बघा, we will not be able to complete, but idea देतो. Vx plus delta x by 2 comma t minus Vx comma t हे इथं आलं, बरोबर. म्हणजे हे इकडे घेतलं आणि साइन बदललं, तर हे मायनस L dx by 2 आणि समथिंग हे इकडे आलं, साइन बदललं, म्हणजे इज इक्वल टू मायनस L डेल्टा x by 2 आणि इथे ब्रॅकेटमध्ये काही समथिंग येणार. मग आता ह्या डेल्टा x ने इथं भागलं तर ते काय येणार आहे, Vx plus delta x by 2 comma t minus Vx comma t upon delta x by 2 त्या डेल्टा x by 2 इथे भागलं सर. तर आणि उजवीकडे काय राहील, L into something. So what this is now, this as delta x tends to 0 ये क्या है? But this term is left hand side का ऐसा है minus. What is left hand side? This is gamma v by gamma x. बराबर है? कारण t कांस्टेंट है. Voltage at x plus delta x by 2 minus voltage at x upon delta x by 2 because delta x by 2. So this term will come gamma v by gamma x. So there will be two terms, or rather there will be four terms. ऐसा क्या एक का ध्यान रखा voltage term gamma v by gamma x, gamma v by gamma t, gamma I by gamma x, gamma I by gamma t, आणि v आणि I एक कॅपिटल काढले. आता मी स्मॉल घेतले ते पण पुस्तकात कॅपिटल आहे. आणि where v and I are, what is v? V is a function of x and t. v म्हणजे v is x comma t ला आपण कॅपिटल असं बोल्ड कॅपिटल v म्हणतो. comma t I the same. So we get a transmission line solution. You derive it now. Again in tutorial you also try to derive. मी आता उलट सांगतो. The solution is gamma 2v by gamma x square is equal to LC gamma 2v by gamma t square. A solution. Gamma 2v by gamma x square is equal to LC gamma 2v by gamma t square. When you derive, and I better same it. Gamma 2I upon gamma x square is equal to LC gamma 2I upon gamma t square. This is for lossless line. Lossless line means what? Lossless line means R0 G0. For a lossy line it becomes complex, and this solution will permit what actual may exist on the line. We shall elaborate later.